Hi guys, welcome to Techie. Today we are going to see about how to deploy Flask app using containerization technology. So in our previous video, we have seen deploying Flask app on IAS. Then why we are going to deploy, we are going to deploy our Flask app on containerization technologies. So first, let us understand the difficulties, challenges faced while deploying on IES. Development team, they will write the code with using some libraries they want and using some environments they want. So all this, they will, after completing the code, they will pass this to deployment team. So well, they will see these whatever libraries required, environments required on this. They will install on the server. But while installing, they face some difficulties. Whenever they install some libraries, they've seen some failures, or when they install some environments, so failures. So these failures will lead to delay in deployment mine. Either to production or testing server, it will lead to delay. So what people came with this problem here is mainly this application is not portable easily, not portable easily. With some time, they may fix this installation of some libraries or some environment. They may fix, but time is a critical factor, and you cannot uh, uh, take a chance on it. So to make it portable, people came with containerization technologies. What containerization technologies is? Entire code plus libraries and environment, they will pack into some image. So that image will be passed on to the deployment team. The deployment team directly just run that image. They need not install libraries and environments for anything. So the application will run in very fast and very within a second they can able to run that application. They can make able to up that instance. So with this portability we have achieved. Understood, right? Portability we have achieved. So before going to demo, let's understand its architecture. How the containerization architecture will look like. So we have kernel, right? Yeah, which directly interacts with the hardware and manages resources for us. And we have operating system where user interacts with operating system, which in turn interacts with the kernel. On top of it, there is container engine. Understood, right? Container engine. This container engine developed on top of it. So using container client, they can build the images, they can run the images. When they run the images, it will create a new container with separate binaries, libraries for that application. It is completely independent. It is like a VM, you can say. It has a host name. This container has host name, separate IP, all the ports available for this. So you can create multiple containers on top of container engine. So we can create multiple. So what all container engines are available is there are many container engines people came up with. Example Docker, Podman, and Podman. So many are there. So for this purpose of this demo, we will see Docker container engine. But Docker container engine is developed on top of Linux kernel system. So if we have a Linux server, just install Docker demo for, and you can build the image and you can run the application instance on it. But if you have Windows, Docker directly not doesn't work directly with Windows. So we need to enable Windows subsystem for Linux. So what is this is it is a Linux kernel type run on top of a Windows. You can assume it as so. Now after installing after enabling WSL feature on Windows, you need to install Docker desktop. Or you can install Ubuntu distribution on top of WSL, on WSL, and install Docker. But installing Docker desktop is its own advantage. It's like you can have Docker GUI is available, and it manages our host machine, Windows machine, and that whatever container image it created, mapping it for us. Everything like basic features required for us, it will be provided by Docker desktop. So without wasting this, let us directly go into the demo of Docker. So now I have a basic Flask app. So on the root, it just returns hello from Dockerized Flask without Ubuntu. So let's remove not hello from Dockerized Flask. Okay. So let's see whether it is running on this or not. So I will activate virtual environment. So I have activated virtual environment. So I will run now app Python app.py. So this is the host. This is the URL. So now let's see. I have already opened. So allow from Docker is Flask. I'm able to open. So it is perfectly fine in our right now. Let's reboot this image. Now, in Docker, I have already installed Docker Desktop. Before installing Docker Desktop, you just need to turn on that WSL, Windows Subsystem for Linux. Here it is there. Yeah, Windows Subsystem for Linux. After that, you need to go to Docker website. You can download this Docker desktop for Windows and install it. After installation, it will ask for restart. You restart it, and you will get the GUI like this. So presently, in the Docker desktop GUI, we can see what all images we have created. There are no images. What all containers it is running. There is no containers. So let's create uh, Docker image for this. For this, to create the Docker image, we need Dockerfile. So already I have a Docker file. So I'll just explain what it is. So we need a base image, right, for running the Flask image. This Python 3.10. This is the base image. You can get this. You can search in a Docker app with this base. If any other environment is required, you can use that base image. And I'm setting the working directory as /r in the container. And after that, I'm copying the requirements.txt to that image, and I'm running install when necessary libraries required for that our application, and I'm copying entire code to that. And when we invoke the Docker image, this command will be running. So to build that image, just we need to run this command. Just so what we need to run? Docker build -t. So what it doing exactly whatever we specified in our Docker file. So we are setting the working directory, copying the requirements file, and running the necessary libraries file, and it is exporting to the image. Now we can open the Docker GI. So the image is available for us. You can see automatically. And if you see the containers, it's still there is no container running on it. So now let's see whether our Flask app is running or not. Flask app is down. Now let's run this container on top using that image. So what we are telling Docker run in detached mode. Detached mode means run it in background. And name of the container we need to give. I'm giving it as a Flask app and port mapping. So port mapping is from the localhost, from our Windows machine. When we type the port localhost colon 5000, it need to run. It will map that request to particular port on the container 5000 of that image, whatever image we supply, we give here. So Flask app is the image. So let's run this command. Sorry, Docker run. So it created the image for us. Let's see, let's verify in the containers whether it is. So we can see the container now we are able to see it is running. We can see the logs also here, like running on so and so. This is the container IP actually, the container IP, and this is the localhost of that container. So let's verify whether we are getting the. We can see, yeah, we are able to see, right? So we have successfully run our run the Flask app using the created image by the Docker. So basically, you enabled the WSL. On top of it, you run on you have run that uh, uh, run the container. So the Docker desktop, if you can see, when you install Docker desktop, it is a lightweight VM created on top of WSL. So WSL is a kernel for the Docker desktop. You can say like that. WSL is running on it, and we can whatever we are seeing in GUI, we can run the commands on the our command prompt directly. See if we can see Docker PS. So present containers running on top of it, where it is our localhost is mapped to which container port and everything we are able to see. And we can see logs of that particular app. Docker Flask app that let's assume again I have requested. Now see, there are only two requests available. Now let's see. I have again 1 second. Localhost, localhost 5000. So let's see whether it is logged or not. So see, we are able to see the logs, Docker logs also here. If any error is there, we can able to see over here. And we can stop that container also. Even you can stop the container from directly from here. You can stop that container from QA. You can use the command prompt also. Mm, If you want to remove the container, you can remove. Even you can do it from GUI also. You can delete directly from here also. And you can see what all Docker images you have created. Also, you can see. We have created tag 1.0. Let's say I have updated version 2 v2. So now I will again create Docker image. Now this time version 2 I am giving. So I am creating the Docker image. Now I want to create a instance of version 2. So again we can see go to the command version 2.0 sorry version 2. You can verify that Docker images command whether what all images are available. Images. See version 2 it is available. Now we will run another instance, but this time local port will be 5001. The as it creates a new container image, let it be same thing. Docker same port 5001. So on this. Okay. We have name given same, right? Flask app 2. If the error is Flask app is already used other container. So we just will give Flask app 2. So we have run. Now let us verify our load instance is running. Yeah, it is perfectly running fine. Whether we are able to get version 2. Yeah, we are getting this one also. That is very good flexibility. We can run multiple instances of same application. Very good feature. And now you have run everything fine. Now you want to share with your deployments team. So how you can share with your deployment team? Like if you have your own registry, your own registry, then you can set up. That is the different thing. I'll show the possible registry available provided by the Docker login. You can run directly Docker tag. You need to provide your username slash Flask app colon 1.0 like that. So Docker push your username slash in this one. If you give whatever builder image you can give, it will go to that registry. Now your deployment team, they will pull and they will run. So what I'm saying is basically Docker hub, Docker hub. You can say like whatever you push there the images you can search here like Flask app. If I push, there are so many people they have pushed that like it's some JC demo they have pushed. So you can click on that. You can pull this image. You can run that in a local machine also. So this is the one of the way to share with your team. Or another otherwise, you can save the created Docker image to your local. Suppose I will just run Docker, save, If output flask app dot tar, the whatever flask app colon 1.0 image. Basically, it will create the tar file. You can see flask app dot tar file. We can share with our team. They can use this Docker load hyphen a flask app Docker, and they can run the command as usual Docker run hyphen port mapping flask app conveyor. They can run this. So we have created the image, we have run the Docker, and even we have seen how to share the Docker image, and we can create multiple versions of our applications. We can run multiple versions of this. Even we can create same versions, multiple instances also. That all possible with this containerization technology. Let's see, is it possible to change the container code in real time? Yes, it is possible. How we can see, take just install Docker extension on your VS Code. Installing. So once you install this icon, you can see containers, what all containers running. See, I have two instances presently running. You can see it has own etc bin libraries, everything. It has own temporary files, user directory, everything, root directory, everything. It has independent. If you can see version 2 also, it has own its own environment. So now as we told, our code will be on app directory. We can see, we can open that file. You can see version 2. If we open that, our another instance file, it is this is version 1. Let's change version 2 code. Version 2, I'm keeping more explanation mark and save it. And now just what we need to do is Docker restart. We have command, or we can directly from QA we can do this. So it is restarting. That's it. So it started. Now let's see whether output we are getting changed. Yeah, we are able to get. So all this flexibility is available with this containerization technologies. I hope you guys like this video. You will be able to use this container technologies, latest technology for creating image and running the instances. But basically, in this video, we have seen only a simple Flask app without any database connectivity. If we have database, it will run as another image. So, but your friend has, like your deployment team has to run that, they need to create the database instance also, right? Uh, you you want to create multiple environments, multiple images. If you want to run, you need to use Docker Compose file. That I will show the demo in the next video. I hope you like this video. Thank you guys for watching. Like and subscribe for the more videos like this. Thank you guys. Thank you.